finding exact values of important angles. So basically the important angles are basically the angles you see on the unit circle. So when we say those important angles, we're referring to those angles. And the reason why they're important is basically they're always going to create 30, 60, 90, or 45, 45, 90 right triangle. But in this one it says find the exact value of sine 300 degrees. So if you type in your calculator, sine 300 degrees, make sure the calculator is in degree mode, you get sine 300 degrees to be negative 0.8660025, roughly. But again, that's not exact value because it actually has more decimals to follow it. I just left those off. So because this can be ambiguous, someone may stop where I stopped, someone else may stop at the 0, someone else may choose to stop at the first decimal and call it negative 0.9 or whatever. We have lots of different possible answers for it, and again, we don't want that. We want to know exactly what it is, and that will probably have square roots in the answer. So to find out exactly what it is, what we do is we create a triangle. So we create a triangle in a unit circle. So the first thing we do, we graph 300 degrees. So 300 degrees would be in the fourth quadrant. So this is a 300 degree angle, somewhere around there. So that's what the angle actually looks like. And when I actually create the triangle for it, I'll be sure that this terminal side has a right angle formed right there. The right angle, if you remember, always goes back to the x-axis. So if that's the case, what we have is a little angle right here, which we can find out, which is, again, our reference angle. This would be theta, or any angle we want to find in this case. So if this is 300 degrees, and this is 360 degrees, well, I know my reference angle right here will have to be 60. So basically what I'm looking at is a small 30, 60, 90 right triangle. And what we know is in a 30, 60, 90 right triangle, the side opposite 60 is considered the longer leg. So this is 60 degrees. And this side will be the square root of 3. And if that's 60, this has to be 30 degrees. So if that's 30, this has to be 1. And if you remember, the hypotenuse is twice a shorter leg. So that should be the sides to it. Only thing I would make sure of, that's going to the right, so it's positive. This is going down, so we call it negative. And if you remember, the hypotenuse is always positive. So what we have right here at this place is a point. The point there will have an x value and a y value. So the x value is along this line, that value is 1. The y value is that direction, and that value is negative square root 3. Make all that a little bigger. So this is what to prepare for it. And if you want to find sine of 300 degrees, if you remember this whole angle is 300 degrees, you really refer back to this reference angle. That's why we call it reference angles, because we always refer back to it when we create this triangle. So if I want to find sine at this angle, we already know it's going to be opposite over hypotenuse. So sine 300 degrees has to be negative square root of 3 over 2 plus negative square root of 3 over 2. If you plug in the calculator, negative square root of 3 over 2, you find that it's about negative 0.8660025. But this is exactly what it is. So this is the answer we want. So I know the sine is actually going to be that. So this is sine of 300. That's the answer we're looking for. So suppose directions were find sine of theta, cosine of theta, and tangent of theta. And theta was, let's say, 330 degrees. So to start off by finding sine 330, you first graph the angle, 330 degrees. And that's going to be in quadrant 4. All right, so 330 degrees is down here. You can draw the whole thing, around that way. You don't have to. Just know that's quadrant 4 and that's what it is. You're fine. So when you actually do that, the next thing would be is make a right triangle and then find out what this reference angle is. So this is 330 and this is 360. Well, that reference angle must be 30 degrees. So if that's the case, I know the sides are 1, 2, and the square root of 3. That's a negative 1 there, because it's going downward. So when you find sine of that, you can right now find sine. You can know know sine is going to be opposite over hypotenuse. So -1 over 2. There's some other things that was find sine too. If you remember from previous videos, we knew the sine of any angle was equal to the y value over r. We knew the cosine of any angle was equal to the x value over r, and then tangent of any angle was equal to y over x. And for that matter, cosecant is r over y, because it's reciprocal of sine, and secant is r over x. Cotangent x over y. So that's an old note you have, and it's useful. So if you look at this ordered pair here, the ordered pair would be, the ordered pair is x first, so square root of 3. And that value is going to be -1. That's a y value. And the r value, we already know that's 2. If you didn't know it, you use Pythagorean there to find it. But if that's the case, here's x, here's y. So it's obviously going to be y over r for sine. So it'd be -1 over 2. So if you use a picture, you can find it. If you use these identities that we know about sine, cosine, tangent, secant, cosecant, and cotangent, you can use those as well. So anyway, we just found sine of 330. We're going to find the other two. Using the same picture, the cosine of 330 will be adjacent over hypotenuse. So it would be the square root of 3 over 2. And the last one, tangent of 330, will be opposite over adjacent. So it would be -1 over the square root of 3, which rationalizes. And you rationalize that, it's going to wind up being square root of 3 over 3. Of course, the rationalize multiply top and bottom by the square root of 3. So that's it. That's how you find the exact value of sine, cosine, and tangent at any angle, any of the important angles. So ultimately, we're going to build into creating the unit circle on your own. So the last thing I'll tell you about is this. Suppose I gave you a sine of an angle that's not one of the angles you can use to make a triangle with. For example, if I find sine of 90, or cosine of 90, or tan of 90, we have to try to create a triangle for that. Well, the angle 90 would be here. So we're looking at that, and it's impossible to create the triangle you want. You can't actually do it. So because of that, it's important to know what these ordered pairs are. So at this point, I know that ordered pair has an x value and a y value. Y is 1, x is 0. So in order to find sine of 90, it's going to be best to know the sine of theta was equal to y over r. Because at this place, there's no way to create a triangle. So this is x, this is y, and if that's the case, it's going to wind up being 0 over r. And if there was a triangle, it'll have that the r value has to be 1. So basically, the r value is going to be the same thing as, it's going to always be either 1 in this problem. It's always going to be 1 in this problem. So it's going to be y over 0 over 1, which is 0. So I know sine of 90 is equal to 0 because that's just what it is then. It's going to be that y value over r, which has to be 1 in this case. I'll give you another one, maybe it makes more sense. So the same thing, find sine, cosine, and tangent all at the angle theta. So if that's the case, theta is -180, so that's in this direction. Of course, 180 is right there. So that's what it would be. So again, there's no way to create a triangle because it actually lies on the axis. So it's best to draw that as an ordered pair. So that was on the unit circle again. This would be an x value. So the x value would be -1. And the y value, because it never went up or never went off the axis, is 0. So again, this is x, this is y. So we want to find sine of theta again, it would be the y value over r, so it would be 0 over 1. So sine of theta in this case is 0. And if I want to find cosine of theta, well, that would be x over r, so it would be negative 1 over 1, because the radius there and the length is the same thing, so it's negative 1 over 1, so it's negative 1. And then tangent theta would be 0 over negative 1, so it's also 0. So sine is 0, cosine is negative 1, tangent is 0. Sometimes you may get things like 1 over 0. Well, if you ever get that, just know this is undefined. So if you ever get one that has a 0 in the bottom, it's undefined. And that's it.